This is section 2.2, part D, assessing normality. The normal distributions provide good models for some distributions for real data, such as ACT scores, IQ test scores, highway gas mileage of a 2009 Corvette convertible, state unemployment rates, weights of 9-ounce bags of potato chips. The distributions of some other common variables are usually skewed and therefore distinctly not normal, such as personal income, survival time of cancer patients after treatment, lifetime of electronic devices. While experience can suggest whether or not a normal distribution is a reasonable model in a particular case, it is risky to assume that a distribution is normal without actually inspecting the data. So let's see what examining data on an unemployment rate in the 50 states in November of 2009. Here are the data arranged from the lowest, which is North Dakota's 4.1%, to the highest, Michigan's 14.7%. Plot the data, make a dot plot, stem plot, or histogram. See if the graph is approximately symmetric and bell-shaped. So if we plot this with a histogram, the histogram of the state unemployment rates is roughly symmetric, it's single-peaked, and somewhat bell-shaped. Now we need to check to see whether the data follows the 68, 95, 99.7 rule. To do this, the first thing we need to do is find our mean and our standard deviation. Now, if you put all of this data into list 1, remember you can do those one variable statistics and find the mean, which is the x bar, and our standard deviation, which is the s sub x. Now you need to find the values of mean plus or minus 1 standard deviation. So you're going to take the mean, you're going to subtract 1 standard deviation, and that would give you this 6.457. Then you're going to take the mean and add the standard deviation and get 10.907. Next, you'll do mean plus or minus 2 standard deviations and mean plus or minus 3 standard deviations. Once you have these windows or range of values, you are going to go up and you're going to count how many of your data points fall within them. So if we go and count our data values, all the ones that are between 6.457 and 10.907, we'll see out of the 50 states, 36 of them fall in that category, which gives us 72%. If we look for all the ones within 2 standard deviations, that means we're going to count all values that are greater than 4.232 but less than 13.132, and that's going to count for 48 out of all the 50 states, or 96%. And for 3 standard deviations, we want all the values that are greater than 2.007, but less than 15.3357, which is all 50 out of 50 states, or 100%. These percentiles are quite close to the 68, 95, and 99.7 targets for the normal distribution. So if a graph of the data is clearly skewed, has multiple peaks, or is not bell-shaped, that's evidence the distribution is not normal. Just because the plot of the data looks normal doesn't mean the distribution is actually normal. So that's when you need to check the 68, 95, 99.7 rule, which will give additional evidence in favor or against normality. A normal probability plot also provides a good assessment of whether a data set follows a normal distribution. A normal probability plot is a graphical technique to identify substantive departures from the normality. This includes identifying outliers and skewness. The data are plotted against a theoretical normal distribution in such a way that the points should form an approximate straight line. So here's how a normal probability plot is constructed. First, you arrange the observed data values from smallest to largest. Next, you record the percentile corresponding to each observation. Use the standard normal distribution, or table A, or the inverse norm on the calculator, to find the z-score at these same percentiles. Plot each observation x against the corresponding z, If the data distribution is close to normal, the plotted points will lie close to some straight line. Now there is a caution. When you examine a normal probability plot, look for the shapes that show clear departures from normality. Don't overreact to minor wiggles in the plot. So when you need to interpret a normal probability plot, if the points on a normal probability plot lie close to a straight line, the plot indicates that the data are normal. Systematic deviations from a straight line indicate a non-normal distribution. Outliers appear as points that are far away from the overall pattern of the plot. Now, you can use your calculator to make a normal probability plot. To do this, you're going to enter all your data values into list 1, so we can use that unemployment rate again. Next, you need to make sure your Y1 is empty, and then hit second Y1, and it'll take you to the plots. You're going to turn plot 1 on, and you are going to select this type of graph. This is the probability plot. Make sure your data axis is X, and make sure your marker is turned on. Then you can use zoom stat, so you can hit zoom and select option number 9, which is zoom stat to see the final graph. So here are the survival times in days of 72 guinea pigs after they were given infectious bacteria in a medical experiment. Determine whether these data are approximately normal distribution. So the first thing we need to do is to plot the data in a histogram. If we plot this, we can see that the survival of the guinea pigs is heavily skewed to the right. If we plot this in a probability plot, there is a clear curvature to the graph, which confirms that this does not follow a normal distribution.